Hello friends, so welcome back. Sanibonani abafundi. Today we're going to do something slightly different in the sense that we're going to use another piece of mathematics that we've previously studied. One of the things we're hoping that you're going to understand through the course of this year is that in mathematics, everything is connected to everything else. So previously we studied a thing called simultaneous equations. Simultaneous equations arise when we've got two equations and each of them has two variables. And these equations, simultaneous equations, can be very helpful in solving questions even in sequences and series, or maybe especially in sequences and series. So let's dive in and take a look at how that looks. So we are going just kind of continuing with sequences and series, but we're going to use this idea of simultaneous equations, and really these connections are very important. Okay, everything's connected to everything else. Right, let's have a look at this question here. Right, an arithmetic sequence has got t12 equal to 80 and t17 equal to 115. Right, let's take a look at what we've got. We know our formula. All right, our formula is just this: Tn is a plus n minus 1 lots of d. Right, I'm going to set up two equations here. I'm going to set up a blue equation. All right, a blue equation using the fact that T12 is 80. That means that 80 is A plus 11 lots of D. Remember, n minus 1, if it's the 12th term, n minus 1. Now there's an equation, but nansi nkinga, because that equation has got two variables in. We can't solve that equation, not at the moment. All right. Kodwa, there's another equation we can make. We can make a black equation using this bit of information here. T17 is 115. So 115 will be A plus, how many? 16D. Yes. Halala. We've got a second equation. Now we've got two variables and two equations. There are different ways of solving simultaneous equations. If we end up with the same number of one of the variables, then we can eliminate one of those variables. And I'm going to show you how we do that. What we're going to do here is we are going to subtract one of the equations from the other equation. Doesn't matter which way we subtract them. When we subtract them, the a's will be eliminated. Let's do equation number 2 minus equation number 1. So we're going to go the bottom one minus the top one. 16d minus 11d is 5d. A minus A, lutho. 115 minus 80, 35. Right, now 35 is 5 lots of d. And what you might want to say now is halala. And the reason halala, now we only have one variable and we can solve for it. D is being multiplied by 5. What should we do to both sides? To get d, we should divide both sides by 5 and we get d equals 7. Once we know d equals 7, we can put that value for d into either equation to get our value for a. Let's put it into equation number 1. So I'm going to go back to the blue pen here. So 80 is a plus 11 lots of 7. Now 11 lots of 7 is 77. So if we subtract 77 from both sides, we get that a equals 3. All right. And so in fact, this sequence is 3, and then we're going to, because remember we need to check, have we answered the question? Work out the first 3 terms. No, we haven't actually finished. The first 3 terms are going to be 3, that's a. Then we're going to add d, which is 7, so we're going to get 10. And then we're going to add another d, and we're going to get 17. Those are the first 3 terms of that sequence. Now, let's just show on Excel that sequence does, in fact, have a 12th term of 80 and a 17th term of 115. Let's just have a look. So it starts off 3, 10, 17. Okay, let's take a look at that. 3, 10, 17. So what I'm going to do this time, I'm going to put 1, 2, 3 in here. These are just the term numbers. Those are obviously an arithmetic sequence as well, so we can go down to them. Right. Now, next door over here, I'm going to put 3, then 7, then, sorry, it wasn't 3, then 7, it was 3, then 10, then 7, okay, we only need 2. Right, and let's go down, right? And let's go and look at T12. Yeah, T12 is 80, right? Exactly as it was meant to be, all right? And let's go and look at T17. There it is. T17 is 115, exactly as it's meant to be. Does it make sense? It always makes sense. Isibalo, injalo. Okay, right, let's minimize that and go back to here and go back to there. All right, now we want you to try a couple. So pause the video, and we're going to give you a bit of time to try both question 11 and 12. Remember, you can talk to your friend. You can discuss it with your friend. You can help one another. The more you help one another, the better you're going to be, right? Because when you explain it to someone else, your understanding is going to improve as well. All right, so here we go. Right, let's have a look. So again, let's sort of color code this. Let's do a black equation. T4 is 23. I'm going to just write down the formula just to remind us. We shouldn't need it at this stage. I'm sure we know it. A plus n minus 1 lots of d. Right, so let's do, in fact, this one with a red pen. So 23 is a plus 3d. All right, and that's an equation, equation number 1. It's got 2 variables. It's a problem. But T15 is 100, so 100 is a plus 14d. Let's now subtract these 2 equations, all right? And this is going to be, when we subtract, doesn't matter which way we subtract them. I'll show you that it doesn't matter which way we subtract them. Let's do 1 minus 2. If we do 1 minus 2, we're going to get negative numbers, but we shouldn't be scared of negative numbers. 23 minus 100 is negative 77. A minus a is 0, and 3d minus 14d is negative 11d. Now notice that both of these are negative. If we subtracted them the other way around, they would both be positive. But when we divide both sides by negative 11, a negative divided by negative is a positive, and we get d is 7. Remember, once we found d, we need to now work out what is a, right? And a, let's use the red equation. So 23 is a plus 3 lots of d. Now d is 7. 3 lots of 7 is 21. I'm hoping you're realizing that it makes a huge difference if you can do the basic arithmetic well. All right, 3 times 7 is a fact. You need to know it, learn it, practice it. Add up number plates of cars when you're driving along. Right, improve your mental mathematics. Now, let's subtract 21 from both sides and we get a equals 2. Right, they ask us, but when you finished answering a question, a good idea is always go back and read it and say, have we answered it? No, we're actually not finished, because they ask us for the first 3 terms. And the first 3 terms are actually going to be 2. The next one is going to be 2 plus 7, it's going to be 9. And the next one is going to be 9 plus 7, it's going to be 16. Okay, and if we carry that on, you'll see, in fact, that the very next term would be 23. And that's one of the terms. All right, let's have a look at number 12. All right. Find the first 2 terms of a sequence which has that. Okay, once again, let's quickly write down the formula. Tn is a plus n minus 1 lots of d. And what we get is 5 equals a plus 60. And we get negative 20 equals a plus 16d. Now, there were 2 ways of solving simultaneous equations. I want to show you the other one. It's actually no easier. In fact, it's a little bit harder for this. Right, but if we were to take from this equation, we were to get a on its own. Now, to get a on its own, we don't want this 6d here, so we're going to subtract 6d from both sides. A is 5 minus 6d. Now we've got an expression for a. And if we take that expression for a, right, and we put it into this equation, all right, then we will only have one variable again. This method is called substitution, because what we are doing is we're substituting, all right, into this black equation, negative 20, sorry, it's come out blue, negative 20 equals a plus 16d, all right, but instead of writing a, I'm going to write 5 minus 60. I'm going to substitute it in. How many different types of variables in there? Only one, Elilodwa. So we can now solve. All right, and let's simplify the right-hand side. The right-hand side comes to 5 plus 10d. All right, now we're going to subtract 20 from both sides, and we get negative 25. And so negative 25 is 10d. All right, so in fact, d is negative. If we divide both sides by 10, we get d is negative 2.5. Sorry, negative 2,5. All right, and if d is negative 2,5, well, 5 subtract 6 lots of negative 2.5. 6 lots of 2.5 is actually 15, so it's 5 plus 16. A is actually 21. All right, so this particular one actually starts off at 21, and the first term will be 21, and the next term we're going to subtract 2.5. That will take us to 18,5. Okay, and so that's that question. Right, let's pendule ikasi turn over. The next sort of one is just another example of the same. All right, and let's just I tell you what, this one's actually asking us to find T8, but what it is saying is, before you do that, try and work out A and D first. Okay, so let's pause the video, try that one together, and then we'll have a look. Okay, so 19 is A plus 4D. And 79 is A plus 19D. All right, I haven't written the equation down. I'm hoping you're comfortable with it by now. That red equation came from there. Let's subtract these two equations. All right, so we're just going to subtract them. Subtracting them will eliminate the A's. 79 minus 19 is 16. It's not 16, it's 60. And A minus A and 19 minus 4 is 15D. So in fact, D is actually, if we divide both sides by 15, we get D equals 4. Now if D equals 4 and we go and put 4 in here, we get 19 is A plus 4 lots of 4. All right, I've put the value of D, this value of D over here, I've put it into this equation over there. All right, there's only one variable left here, so 19 is A plus 16. Let's subtract 16 from both sides. A equals 3. So we know A and we know D. Now, the question actually asks us to find T7. T7, not T7, sorry, T8. T8 is going to be A, which is 3, plus 7 lots of D. Now D is 4. 7 lots of 4 is 28. 28 plus 3, 31. There's our final answer. Okay. All right. Often what we need to do is we need to interpret a real life example given in English. So let's look at an example here. Taubo runs 500 meters on his first day of training. Thereafter, he runs 300 meters further each day. How far will he run on the 8th day? Well, let's write down some terms. On day 1, he runs 500. On day 2, he runs 800. He runs 300 meters further. The next day, he runs 300 meters further again, 1100. What sort of sequence is this? Yeah, it's an arithmetic sequence. Each term is telling us how far he ran on each day. Term 3 is how far he ran on day 3. So to find out how far he ran on day 8, we need to find T8 of this. Is that easy or difficult? I think it's quite easy. We know our formula. Let's just write it up in case we're forgetting it. But our formula, Tn is A plus n minus 1 lots of D. Right. Now, so T8 is going to be 500 plus 7 lots of D. Now, D is 300. 7 times 3 is 21. So that's 2100 plus 500, 2600. 2600 meters or 2,6 kilometers. Okay, let's look at the next one. It says, on which day will he first run more than 10 kilometers? What we're going to do here is we're going to work out which term is equal to 10 kilometers. But be careful, we can't use 10 kilometers. These are in meters, so we've got to change that to meters as well. So let's take a look. 10,000 is going to be A plus, we're trying to find out the term number, times by D. Right, let's subtract 500 from both sides. And here we've got 300 lots of n minus 1. How can we get rid of multiplying by 300 on both sides? By dividing by 300. That will give us n minus 1. What should we do to both sides to get rid of this minus 1? The inverse of subtracting 1 is adding 1. So n is actually just going to be 95 over 3. I've divided the top and the bottom by 100, which is a perfectly acceptable thing to do when we're simplifying fractions. So that's going to be our answer for n. Now let's take a look at what that actually comes to. All right, 95 over 3. 95 over 3 plus 1. And we get 98 over 3. We get 32,7. N equals 32,7. Now what that tells us is that there is not a day on which he runs 10 kilometers. On the 32nd day, he will be a little bit less than 10 kilometers. And on the 33rd day, he will be a little bit more. So the answer to the question is day 33. Day 33. Okay. Right, we're going to ask you to pause the video and we're going to ask you to try the next one. All right, the next one is, I see that I've got the answers up here for you, but I'm going to get rid of those quickly. And I'm going to pause the video and we're going to ask you to try them. Okay, let's take a look. So let's write down some terms. On the first day, she swims 4 lengths. 4 lengths of 25 meters, she swims 100 meters. The next day, she swims 2 extra lengths. She actually swims 150 meters. The next day, she swims 2 more lengths. She swims 200 meters. What sort of sequence is this? This is arithmetic. Do we know A? Yes. Do we know D? Yes. Can we work out the 8th term? Because each term is telling us how far she swam on a certain day. Yes. The 8th term is A plus 7 lots of the common difference. The common difference is 50. All right, 7 times 5 is 35. So 350, 450 meters. That's how far she swims on day 8. Does it make sense? It always makes sense. Okay, on which day will she first swim a mile? There's a race at Midmar Dam called the Midmar Mile. All right, that's 1.6 kilometers. 1,600 meters. So what we want to know now is which term is equal to 1,600. Okay, so let's remember our formula. Tn is A plus n minus 1 lots of D. All right, and let's put the 1,600 here. A is 100. N we don't know. D we know is 50. Right, we're trying to solve this equation. There are different orders we could work in, but let's subtract the 100 first. We get 1,500. So 1,500 is 50 lots of n minus 1. Now let's divide both sides by 50. Now 1,500 over 50 is actually not that difficult to do, because we can divide the top and the bottom by 10. So now what we've got 150 divided by 5, right? 5 goes into 15 3 times, so it'll go into 150 30 times. So n minus 1 is actually 30. What should we do to both sides to get n? Obviously, we must just add 1. And so the answer is on the 31st day, she will first swim a mile. The next day, she'll swim more. All right, we're going to stop there. We hope you enjoyed the lesson, and we look forward to seeing you next time.